You mentioned like there are types on the edge of the system that you have to define and that's your like barrier of soundness, right? Like things outside of the Rescript code are unsound. And TypeScript has this same problem, right? They have to define type definitions for everything. And like famously, TypeScript has now at this point in 2025 just a ton of type definitions for everything, just about. Definitely typed has a ton of types in it, but there are like most libraries these days, it seems like they ship their own TypeScript types. So when you think about Rescript's interop with the rest of the JavaScript ecosystem, or like defining types for outside things, is like, what is the story around that?
I would say this is definitely one of the points of the language where we have a lot more work to do, or rather in the ecosystem, I would say. In Rescript, interoping with JavaScript or TypeScript, you write bindings, which essentially are ways of describing that if you call this function in JavaScript, you're supposed to expect these parameters, it returns this thing, and so on. It's a description of what the outside world looks like. And then you get access to those functions in Rescript, and the emitted JavaScript is just what you'd expect, like the calls for JavaScript. The big issues that we have around this is that while Rescript and JavaScript has a lot of similarities, there are also a bunch of things that you do in Rescript, in TypeScript and JavaScript that you don't do in Rescript or can't do in Rescript, so to speak. Overloads is an example. Rescript doesn't have a concept of overloads, which is something I've really come to appreciate in the sense that it's very clear, like exactly what things can do. But it also means that you can't one-to-one express a TypeScript with code with overloads in Rescript without breaking out each overload to its own kind of function binding. So there are like differences in the type systems that make, because what people come to always is, can't you build a tool that automatically generates Rescript from TypeScript? And back before all of the TypeScript wizardry, this was something that people were exploring, but the results were never really satisfactory because of both the fact that it's quite different type systems, but also that writing the bindings is an art, so to speak. Like you usually when you use a library, you're very seldom using all of it. Most often you're using a small part of it, and you want to use it in your specific way. And there's a bunch of ways to write bindings in Rescript that lets you tailor the API a bit in how it looks. So like you can inject default values for arguments, for instance. So one classical example is the read file sync API of Node, or read file for that matter. Doesn't have to be the sync version, but that takes a file path, and then you can pass it a string of the encoding, right? The encodings in most cases is going to be UTF-8. So you can create a binding in Rescript that has a default value of UTF-8, a string, for the options parameter. So you never have to write UTF-8 in Rescript, but the emitted JavaScript always has UTF-8, but it's not wrapped in another function. So it's not a wrapping on top of the Node API. It's built into the binding itself. So like writing bindings is an art, so to speak. But then we have also going the other way, going from using Rescript code from TypeScript. And luckily there we have a bunch of nice stuff in Rescript. We have a tool called gentype, which you just annotate your types and Rescript functions and values, and then a TypeScript file for each Rescript module gets generated with all of the types in TypeScript, but translated from Rescript, so you can easily use them. But this, like the binding space, is of course a big problem. It stems mostly from, I would say, from us being a small community. So definitely type nowadays it has everything and then some. But back in the day when TypeScript was fighting it out with Flow, essentially, it also had a bunch of things, but most were any stubs, right? The same with Flow typed and all those things. So we're at that stage now where when we grow, when we grow a lot, there's going to be quality bindings. But it's also a thing where I think people overestimate how much they use libraries and how much time they would spend writing the bindings for those libraries. But it's a thing where it's hard to say anything else than this is a problem, essentially. AI is going to help some, like teaching the AI to write good bindings helps. We're also experimenting with, so like Rescript can emit TypeScript as an interop layer, so you can call Rescript code type safely from TypeScript. But we're also experimenting with, okay, so can we have Rescript, the compiler, or gentype, the tool? Can we have that emit a file that just checks that the bindings you've written would work with the TypeScript types of that library, so to speak. So if I have this binding for, we'll say React, for instance, for use memo or whatever, is this function signature of the binding I've written, is that compatible with the use memo from the React types package, so to speak? So we're doing a bunch of exploration around how we can improve the situation, because it is a problem. If you're in the blessed path, like you come in and you work with React, for instance, where we have great bindings, and a bunch of other libraries where we have great bindings, then you're pretty much set, like it's going to be fine. But if you need to wander off yourself into writing bindings, it can be daunting.
So code is just the tip of the iceberg when it comes to the JavaScript world. For better or worse, we have lots and lots of tooling. We have linting, testing tools, bundling tools, build tools, all different types of tools. What's the story for Rescript integrating with those? Does it like boil the ocean view of it and do it all for you? Or is it interoperable with the common tools we use today?
Yeah, one of the goals of Rescript is to integrate as cleanly as possible into the JavaScript world. So this means, for instance, you use NPM or PNPM or whatever you want to use, but you use the JavaScript ecosystem for packaging, for instance. You use the same bundlers. What Rescript does is, for each Rescript file, it will emit a JavaScript file that looks as handwritten as we can make it look, essentially. Like it's supposed to look roughly as what you'd write by hand in JavaScript. Our goal is to integrate like cleanly into all of those things. Your bundlers, linting, of course, is a thing where it makes more sense to do it in Rescript itself, to lint in Rescript. We also linting is another topic, but we don't have that many linters because we have such a tight type system. We have a couple of compiler warnings and stuff, so we haven't really seen the need for that. But you could lint and I know people do, you could lint the JavaScript output. People use the React hook lints, for instance. We did a bunch of work we have a version 12 that's coming up here soon. We have done a bunch of work for making sure that the Rescript output can work with the React compiler, for instance, efficiently. All of those things that comes with having a goal of interoperating as cleanly as possible with JavaScript.
Yeah, I was going to ask that when we got to the React section, if it integrated with kind of the bleeding edge tooling of the React ecosystem. That's super cool that you can run stuff on the output and it's good enough output that you can translate that back to the Rescript code.
Yeah. Typically, this is a bit of an aside, but do you typically check in the JavaScript code?
I don't actually, but it's a problem. We usually recommend you to check it in. I find it a bit noisy, but I've been working actually quite recently on, okay, so if we don't check in our code, how do we make sure we don't miss accidental behavioral changes? Because imagine, go back to this thing with, we have a sound type system, I make changes, it compiles, I can trust it. So that's good, but there's another layer in Rescript, which is the emitted JavaScript. So what if there are changes in the emitted JavaScript that I wasn't anticipating? Now, the compiler is very well tested and everything, so it's not, you can trust output. But still, when you do refactors, when you do bindings, when you do upgrade versions of the compiler or other versions of libraries, and it can be nice to just scroll through the actual JavaScript changes. Also, when you do a refactor that's purely on the type level or something like that, you restructure how things work. It's nice to, when it compiles and you also see that there are no changes in the actual JavaScript, then it's going to work, right? It's not going to be any behavioral changes because the generated JavaScript is the only thing that matters to the end user, because that's what gets run. I've been exploring building a sort of a diff tool for that. So you could have a CI action that always gives you a HTML diff page you can scroll through for that. It's also interesting to do that type of diffing of the code you made purely at the type level. So we could have that's for generated JavaScript, you diff the generated JavaScript. For the type level, you could have a diff that just shows how the type signatures or the type output of all files have changed, so to speak, so that you haven't also accidentally made any changes that you weren't anticipating. And for us, a goal is also that all of these things should be easy to plug in an AI that can do, for instance. So an AI could audit your generated JS changes or your type changes or whatever. It's always nowadays it's always in the back of the head that it's supposed to work well with that as well.